Good morning, everybody. First thing I want to show you today is some satellite data from Saturday. This is using NOAA's VERS satellite. And we're just capturing the very beginning of these wildfires that were in parts of Quebec. Now, back in May, we saw massive wildfires over in British Columbia and Alberta and Saskatchewan. And here we are now at this point in June, and those fires have really moved into the forested areas here in Quebec. Some of the smoke was being pushed farther and farther to the south over the weekend, really degrading air quality throughout much of the Great Lakes Basin. I can show you some of that by looking at the GOES satellite data here from yesterday on Sunday. And again, you can see all of that wildfire smoke in through this region. Now, this particular region also had some very dry air that began to invade into this area, and it's going to be interesting to see how low those dew point temperatures can get and how dry this air is. But once again, we saw throughout the afternoon just large complexes of storms just rolling, from a broad sector here of the country, from parts of the Tennessee Valley through the Missouri Valley, parts of the Mississippi Valley, but mostly the western side of it, and then throughout the plains. And that's been a really constant theme for the last several days. We're going to take a look in a few moments at what those precipitation totals look like. But before I kind of leave off on this, what the smoke has been doing, take a look at the forecast loop here over the next about 24 hours or so and where we're expecting that smoke to continue to go. So again, there's going to be air quality issues throughout much of this part of the country as the wildfire smoke from Quebec continues to get pushed into this area. There's still quite a bit here too that is moving through the Canadian archipelago and then down through the Hudson Bay. So just to get an idea about what this flow pattern is up to. So speaking of the flow, this is what I've got today. And a couple things just to take note of. We're going to continue throughout this week to see very weak flow into this area. What you've got here, this is helping to deliver some extremely dry air into the Great Lakes Basin. And this is going to be a near constant theme for California over the next 10 to 15 days. These low pressure cells that just keep kind of forming here on the nose of what is our subtropical jet. And that's going to keep things quite stormy throughout California right now in these first couple of days of this week. And you got to remember, we still have a tremendous amount of snow that is in the Sierra Nevada. In fact, I want to show you that real quick. If we just kind of slide over here and have a closer look, there you can see that snow in the Sierra right there, Sierra Nevada mountains. And so a lot of this still has to melt. We're going to add a lot of thunderstorm activity to this, and there's going to continue to be flooding down here in the Tulare Basin. You can see the discoloration here. This is some ongoing flooding in this area. Another thing to point out here is we are going to be watching for the pattern to begin its shift this week. We've been kind of just monitoring this particular week, this 7-day time period, as the transition time period to start to deliver some rain to people that need it. Is it going to break the 25 to 35 day drought that we've been in? It is not. For some people, though, it's going to just buy us some time. But what we're really waiting on in this pattern is actually still way over here. The Bermuda High, which normally sits here, is now kind of elongated and sitting somewhere in this area. It has yet to fully just regain its control and position to set up as a big subtropical ridge here. And that just is something we talked about last week as being a problem with this pattern. Okay, back to the near term. Watch this. This is a forecast of dew point temperature. So not temperature, but dew point temperature, the temperature to which you have to cool the air to get it to saturate. So it's a measure of the moisture. And look at this whole region in through here. We have dew point temperatures today, where I live, that are actually below freezing. So if we wanted to get to the dew point temperature, we'd actually have to have a frost in this part of the Ohio River Valley. Same thing for New England. And as I play through Monday into Tuesday, that dry air is firmly in place. This is Wednesday afternoon and evening. Everywhere that you see that hard break with the black contour line and then the much colder looking colors, that is where that dew point is so low. So this is a front that's sliding in through this area throughout this week, and we could get some showers and storms on its leading edge, but you got to get into the moisture for that. So there is drier air. There is cooler air coming into this area, which is going to help back off some of the heat stress that was here from the last week, but there's not much moisture in that. What we're waiting for, again, here we are by the 8th, 9th. There's the depth and penetration of that drier air. We're just waiting past this end of this week for the moisture to begin its return. And we start to see it coming into some very, very dry locations. So there we go. We're trying to watch for these drier impulses to get out and get moisture to come back. But the reality of it is this, and I should have learned my lesson over the last 25 years doing this. Usually when you're in a drought and you see the models attempt to break the drought with better precipitation signals, almost every time we see that, the the pattern gets kicked down the road. We always say, like, well, it's going to be here in 8 days, and then it's going to be here 8 more days, and then 8 more days, and we just keep doing that until finally some things start to shift around and break. The good news is there is still indications of this pattern beginning to make that kind of shift. Now, over the next few days, just take a look at these 3 maps right in the middle of the page here. No, large areas of organized severe weather, but everywhere that you see this shade, we're going to be watching for some stronger storms. And that does include parts of California and the Pacific Northwest. So why don't we pick it up here with the high-res model and get a good look at this. So playing throughout the day today, again, it's going to be an afternoon where if you are in this corridor, I'm going to highlight the areas that are drier. Everywhere outside of what I just kind of sectioned off here, storms. We're going to see isolated storms continue. That's 4 o'clock this afternoon Central Time into the evening hours. This is now getting into Tuesday morning, Tuesday midday. You see the front coming down? There might be some isolated showers on the leading edge of it. But you get out here to Wednesday morning, that's where that front will be, and the very dry air that's coming in behind this. Now, to put all this in context, here's the last 7 days of total accumulated precipitation as captured by the MRMS data set. And again, we had what was eventually named Arlene. That was the tropical system that just kept going south. We had this anomalous easterly flow that as you got closer and closer to the mountains, give you upslope flow and just more and more storms. And then we had the weak waves, the shore waves that were coming off of the Pacific and kind of curling their way around, making for the storms that were from, this part of California clear to Montana. But in reality, if you look at this map and we compare it to what we saw a week ago, in fact, I'll do that in tonight's in-depth report, you're going to notice that in many places the model underestimated total precipitation. And that's because these longer range models that forecast out a week, they are not like the NAM. Oops, where was the NAM? There it is. This is convective allowing. The ECMWF and the GFS are not. Convection is parameterized. So it's never going to be able to see these heavy rainfall events and not capture the isolated storms like we saw in parts of Ohio, Kentucky, Tennessee, Indiana, Illinois, Wisconsin, Missouri. These are areas that are deep in drought that did, some locations, get some locally heavy rain. But the farther west you went, the better the rainfall was, better the coverage was. So what does this next week look like? Well, this is total accumulated precipitation by the WPC. And if it looks similar to what we've been talking about for the last few weeks, it is. But it is now beginning to capture the change in the pattern that could start to deliver rain into some places that have been very, very dry. And I know right now there's a lot of discussion that the markets are trading model runs, but I want to make one thing very clear about this. That's very speculative, and here's the reason why. This is the newest ECMWF run. You're always like, well, why don't you show the model-to-model differences? And I'm going to show you why I don't do that, why I stick to the ensembles. Because if I play through this week, let's just pause this out here by the time we get to, Friday morning. There are scattered storms that are going to come through this area. It's not going to fill in the holes, but it's going to be there. The storms continue to run upslope, and that's what we've got here. We have the very dry air come through the Great Lakes Basin, but then you get out there to Saturday, into Sunday and Monday, and we're going to watch this front that's going to try to come through this area, but it's still a week away. Okay, all of this heavy precip, this is all coming around the Bermuda High trying to make its return. But you see these streaks of precip, and if you've watched the 7 to 10 day forecast, they've really changed a lot in position. Well, that's the European model's forecast for this week. How about the GFS? We come out here in the same time period. Let's just pause it right there. You look at these two and you're like, wow, they have different solutions for this. And absolutely they do. And that's because model error increases with forecast time. And if you're curious as to how much, watch this. This is an animation for the 96-hour time period ending a week from now. Okay, so that's it. And what I'm going to do is I'm going to click and show you how each model run has changed. In other words, everything you're watching me click through here is for the same time period forecast by the GFS. These are just different model runs showing you the different solutions. Some of them come in and you're like, I'm from Illinois. So I look at this and I'm like, yes, bring all of this in. We need this. Then I get a model run. Oh, wow, that would have been perfect. But then the next one came through and it's like, no, nothing. And that's what happens. And it is worse in summer because of what I shared with you earlier. These forecast models that make these maps, which we love, which not that one, but this one and others, they are non-convective allowing. Its convection is parameterized. And what's convection? It's thunderstorms. So this is why we have to heavily rely on the ensembles. And if you've seen me draw on any map, you know that for this forecast time period, I have done this multiple times as to this being the corridor of best chances for wettest weather as we approach the 10th of the month. So between now and the 15th, that would be the next 10 days, this region right in through here is our best chance at picking up our heaviest rains. This is the probability of getting at least an inch of rain over the next 10 days. What is important is some of these very dry regions throughout the Great Lakes Basin, the Ohio River Valley, are now no longer zero. And the probability of getting less than a half inch has backed off to 40 to 50%, some places 60% around the Great Lakes. That's the transition we're talking about. Is it going to undo this? No, that's never been in my forecast narrative. We were just looking for something to change and bring in moisture to this area. If there's one piece of this that's kind of just saving to it, is it's going to get cooler in this area. So we are expecting less overall stress. But this map is the last 30 days of percent of normal precipitation. And as you remember from last week's videos, we know that there are pockets here that are sitting between 600 and 1,000% of normal. You then have places here that have measured nothing. And to really put this into contrast, the rain, the last time we had good rain for a lot of this area was May 10th. So from May 10th till yesterday morning, there are now numerous climate reporting districts in the upper Midwest, the Great Lakes Basin, New England, that have that number 131 in them. When you look back again, May 10th through June the 4th. And that would mean it's the driest in lower Michigan's history for that time period. Same thing for parts of Pennsylvania and New York, while we're still so very wet in this area. And there's a lot of incredibly productive agriculture in this area that is desperately needing moisture to come into this region. One of the things I want to remind you is, because I got a lot of questions about this, well, we've seen a lot of flow out of the east, and normally we think about flow out of the east as being an indicator of rain. That's true in fall, winter, and spring. But in summer, if where the air is being sourced from is so dry, which is here, which you just saw at the beginning of this where those wildfires are, there's nothing there to precipitate. So that's why we've increased the chances as this goes upslope for better storms. Now from here, I want to show you, we are watching still a transition. The MJO is moving into the Indian Ocean right now. The jet's extending, and I want to watch very carefully what the subtropical jet does by Friday, Saturday, and Sunday. Because at that point, here's the ridge. It had been over Minnesota. It's now moved back to Alberta. And we start to see going into early next week this, and this is it. This is what I waited for. This came through and knocked out the ridge here. This is now pushing to British Columbia, and there's a piece of the flow that's almost going high over low, kicking off better chance of southwest flow here. The subtropical jet is coming into this area to start to improve precipitation chances. It's still 7 or 8 days away. But what I've got out here for the middle of the month is a setup for a lot of storms in this area. That's it. It's still there. So the week 2 precipitation anomalies, look at what the government came up with, the CPC. There's that corridor we keep drawing. It's still here in the European model. But if you're in the upper Midwest, it's actually on all 3 forecasts. It's still looking to be drier. That drought area and through here is of top concern going forward as we start to see some relief farther to the south of it. Now, as I mentioned, the temperatures are at least not going to bake this area. Here's Monday's highs, but as you get into Tuesday and Wednesday, there is cooler air coming into this region. It's very dry air, but cooler air. The heat's in the northwest. California, you're going to avoid heat stress just continually. This is going out to Friday and Saturday. We start to bring back in some summertime warmth here, but there's at least some relief in that overall heat. Now this gets us out to next Sunday, and from now until then, if we take a look at GDDs getting added up here, we still see some very high numbers in the midsection of the country, but cooler and cooler. In terms of total evaporation forecast by the National Digital Forecast Database, there are a few sectors in through here that are going to pick up more than 1.5 inches, maybe approaching 2 inches. All of this is normal, and it's a little bit higher than normal in the Columbia Basin. Finally, this is what the forecast temperatures are expected to do. It's a 5-day sliding window. It's my favorite animation. I show it to you all the time. That's day 5 through 10. Where's the heat going? With the ridge back into Western Canada. And this is when we expect to see just better chances. I can just do it again in this corridor of storms. Now we get out here later in the month and heat starts to build back in. But what the hope is that this heat is building in because the subtropical jet is bumping in like this, and there could be the return of the Bermuda high. And so that heat brings in moisture and storms, and that's what we want to see for the very dry regions of the country right in through here. So we're still watching for this. And our government last week released this from the CPC. This is their basically end of June forecast. You see that warmth that could be prompted and helped by a subtropical ridge, some southwest flow, cooler, warmer, and that's where we're hoping to see this area be eroded away from its drought picture. But there's still a lot on the table. We're going to watch it every day and look forward to giving you those reports. Have a good one. Thanks.